we're going to talk about, from lesson 3.5, arithmetic sequences. Oh, hold on. Okay, so an arithmetic sequence. And we are at 114, month away from Valentine's Day, boys. Keep that in mind. And arithmetic means what? What does that look like? Arithmetic. Okay, and when we talk about arithmetic, what operations are we talking about? Math is not an operation, dude. No, you would think that, but not in this case. Good guess. All right, so we're down to 3 operations possible.
Addition, subtraction.
Multiplication.
No, you need to say it with a commitment, not Mr. Drop My Pencil, bam.
Solids, liquids.
Say, Johnny Ray. Okay, Johnny Ray at least has his stuff working for him. And when we talk about arithmetic sequence, we're going to be focusing in on patterns involving adding and subtracting. Because remember, subtraction can get rewritten as an addition problem. Now, there is a different type of sequence called geometric. That one uses multiplication and division to develop its pattern, but we're not going to study that one. Okay, so we're just going to do this one. And again, the part you're going to do tonight is just like, what are the next 3 numbers in the series? Okay, so, or the sequence. But first off, I want to deal with this idea of the word sequence. So I'm just going to cram mine on here, but we're going to do kind of a large size for our model so we can give ourselves some room. If you feel that, I'm trying to think, how much do I want to get on there? You probably can do it just going across your paper, maybe taking about half of what's left. You don't have to turn your paper sideways. If you feel more comfortable giving yourself some elbow room, you can turn your paper sideways, but that may make for a weird spot for doing the examples, okay? So we're going to put in here, so this is not arithmetic sequence, this is just what is a sequence. I will kind of cater the information to the arithmetic one. And so we have a definition is up here, characteristics is over here, examples, and then we have non-examples. Let's do. Okay, so for our definition, a sequence in general. Okay, so the sequence is an ordered list of numbers. Okay. So a sequence is an ordered list of numbers. Now, we are going to deal with the notion of patterns, but patterns can be all sorts of stuff. I'll give you a pattern, see if you can figure out what would be the next in the pattern. MTWT. That's a pattern. Nope. MTWT. Nope. Jaden? Why? It's the days of the week. Monday, Tuesday, Wednesday, Thursday. MTWT.
Get out of this class. We're not high school. Dude, what are you doing?
No, he's perfectly placed in the class. Friday. Now, when I taught geometry class, that was often some of the patterns they had to deal with, because again, we're dealing with this notion of logic. And so, but for us, when we're dealing with sequences, it is based on math, that's addition, therefore we have to have numbers, okay? So we do have sequences that are deal with numbers only, and then we also have patterns. So there's a slight difference. But a sequence involves a pattern. Okay? And something that isn't number related then is just called a pattern. Okay? So let's talk about some characteristics. Now, we aren't going to talk about the second one today, but we'll talk about it tomorrow. So first off, the numbers in the ordered list are called terms. Okay, so that's one thing. The other one, again, this we'll talk more about tomorrow. A sequence may be named or referred to as A or A sub n. Okay, so again, we're not going to deal with that lighter blue comment today, but tomorrow we will. Today we're just going to play around. Tomorrow we're going to figure out how to get numbers way down the line, not just what comes next. Okay, so let's talk about some examples. Okay, this is a sequence that you've probably worked on since kindergarten, even preschool. So if I asked you what would come next, you would tell me?
7.
Yeah.
7, 8.
Wait a second.
6.
7 comes after 5?
6, sorry.
Holy smokes! You get out of the class. Yeah, jeez.
Go back to kindergarten.
Oh, jeez. Okay. What would be the pattern that you see going on in that problem? Yeah, you just add 1 every time, okay? They're consecutive integers. Ooh. Okay, how about this?
Subtract a negative.
Do you see subtraction going on here, Michael? Did you see subtraction going on in those? Are those numbers getting smaller?
Subtracting a negative number.
That's not how you read.
Oh my goodness. Smarty pants. All right, this, what would you predict would come next? 12.
Maybe 12.
I'm going to have to seriously go outside and cry. Okay, yes, this is a pattern. These are consecutive even integers. Let's see if you guys recognize this one. And by the way, these are arithmetic patterns.
It's 11.
Okay, who can tell me what would come next on this one? Okay, Morgan?
I got you. So like you add the number before to it.
Okay, so
So like,
walk us through it.
So like you add 1, and I guess there would be 0 before that. So 0 is 1, and then you add 1 to the other 1, and then you get 2, and you add 2 to 1, and you get 3, and you add 3 to 5.
Okay, so this sequence is very famous, and it has a name. Anybody remember the name of this sequence? It's named after a very famous mathematician, though I believe is somewhere on our wall. Yes, he is. Okay, no. For the record, any of you who are watching this video who are not in my class, these are my accelerated students. They tell me. Okay, just so that you know. I do get asked that question. What level do you teach? I'm like, I don't know anymore. I don't know anymore. Okay, this is called the Fibonacci sequence. And the Fibonacci sequence is famous because it exists in nature. So you might want to check it out sometime. There's some beautiful things being done with it. Okay, so those are sequences. There's a pattern. I can do predictions of what's coming up next. In the first two, they were simple patterns, add 1, add 2. And the second one is a little bit more complicated of a pattern. I had to figure out how did I get the next one. Oh, I added the 2 before. Okay. All right, so let's talk about some non-examples. A number on its own is not a sequence. It's got to have a group of numbers that are listed, separated. So a constant is not a sequence. How about, what if I have plus signs between them? Is that a sequence? And the answer is it's not a sequence, because a sequence is just a list of numbers. When I'm trying to do math with them, this is now called something else. This is called a series. Now, we aren't going to study series in this class, but you will be studying series, geometric sequences in other classes, okay? Formulas. So an equation is not a sequence. Okay? All right, so let's talk just a little bit about the arithmetic sequence. We have one more term I want to share with you. Beyond what we have, we already mentioned that the arithmetic sequence is a pattern that uses adding or subtracting to get from one number to the next. And that number that we're adding or subtracting by is constant. With the Fibonacci sequence, it was different because it was not necessarily an arithmetic sequence. It was a good pattern. But here's the interesting thing. If you take that pattern a deeper level, it now becomes an arithmetic sequence. It's kind of strange, but don't worry about that. So the difference between the terms gets the letter D, and that's the value consistently added or subtracted to get the next number in the sequence. Oops, that did not spell out. There we go. Okay, so we're going to be referring to this D variable, which represents what is that actual pattern number? What am I doing to get from the first number to the second number to the third number? And it's got to be the same thing, otherwise it's not considered an arithmetic sequence. So we've got a, let's just do a couple different examples. Let's see, how about determine the pattern, then give the next three terms in a sequence, in the sequence, I should say. So let's do, we haven't done a one that looks like this. So one of the first things that I do when I'm looking at any sequence, and this is back in the day when I could be covering either arithmetic or geometric, knowing for us we're just focusing on arithmetics. First thing I would look at, are my numbers increasing or my numbers decreasing? Okay. So if they're increasing, what do you think the math is going on? So if you increase from one number to the next, you're subtracting the same value every time? So 1, 3, 5, 7, I'm subtracting something from 1 to get to 3? No, I'm adding. Okay, so with increasing, I have an add pattern. And with decreasing numbers, I have a subtraction pattern. So you notice this set of numbers, am I increasing or decreasing? I'm decreasing. So that means I'm going to look for what is the difference between the numbers. And I start with the first two, and I say, okay, what do I do to get from 33 to 29? Well, when I subtract, I get a difference of 4. So my suspicion is that's going to be my pattern, so I check it out. If I take 29 and subtract 4, does it give me 25? And the answer is yes. But I got to keep checking. If I take 25 and subtract 4, do I get 21? And the answer is yes. If I take 21 and I subtract 17, I get 4. So what I've just discovered is the D. The D is what's the difference. In our case, it's a negative 4. Can we focus? Okay. So now that I know what the pattern is, what my D value is, I can come up with the next 3 numbers in the sequence. What would come after 17?
13.
What would come after 13?
9.
Yeah, that one I was hesitating. I was worried about that one. And what would come after that? 5.
2.
And that's how you do this, okay? So we'll do one more, and then I'll talk about something you have to watch out for. Let's do, how about, this one gets a little interesting. Oops, sorry, let me go back to black. So we've got -4, -2, 0, 2, ... And by the way, they do make a comment about the 3 dots. It's called an ellipsis. And what the ellipsis says is that there's more numbers in this pattern, but we're not listing all of them. So it goes infinitely on. So I'll just write that in there, add that in. This is called an ellipsis. Ellipsis. And you could interpret it to mean and so on. Okay, so let's see if we can figure out our D. What are we doing from -4 to -2? How about from -2 to 0? And then we add 2. So what we can notice quickly, and you don't have to start with a -4 and -2. You could go to the odds, or to the down the line where it's positive, 0 and 2. Check those out. And then once you check them out, say, I think the pattern is adding 2, then go back to the beginning and see if that pattern works. Okay, so what would be the next 3 numbers in the sequence? Okay. All right, so first thing I'm going to tell you is they are going to give me some, or give you on your homework tonight, if it's arithmetic. So your job is to first see, can you find a common D? If there is no common D, then it's no, and you can't figure out what happens next. Okay, then some of the problems are, they tell you this is an arithmetic sequence because they say find the next 3 numbers in the sequence. And the only way you can do that is if it is a sequence and there is a pattern established. You have to figure out the pattern, the D again, and then come up with the rest. All right, that's it.